I want to do a couple of problems from homework number 6, section 4.2 on the multiplication and addition rule. These are about the multiplication rule. The first one, it's actually the number 9 and number 10 in the homework. The first one is an example of the multiplication rule, which assumes sampling without replacement. And the second one uses the 5% rule. So here's the example. It says, using the data in the following table, assume orders are randomly selected. If 3 different orders are selected, find the probability they are all from restaurant D. So the first thing I'm going to do is figure out what the total number of orders are and how many there are from restaurant D. So on the calculator, I wrote down these numbers. I'm adding up 326 plus 269 plus 238 plus 136, and then in the second row there, plus 38 plus 57 plus 39 plus 15, and that gives me the total number of orders. We're talking about 1,118 orders. I'm going to write that number down, 1,118. And how many of those are from restaurant, which one did they want? How many of those are from restaurant D? So it's 136 plus 15 are from restaurant D. So back to the calculator, 136 plus 15 gives me 151. Okay, I'm writing that down. So it's 151 out of 1,118 are from restaurant D. Okay, now the question says, if 3 different orders are selected, find the probability they're all from restaurant D. This one, we're going to do what they call sampling without replacement. So when the first restaurant order is made, there's 151 from restaurant D out of 1,118 total. Okay, now that order has already been removed from the group. And so for the second order, it's 150 are left from restaurant D, and there's only 1,117 total orders. And if the first 2 are from D, then for the third order, there's 149 left from restaurant D and 1,116 total orders. So to get the probability that 3 orders are from restaurant D on the calculator, I'm going to multiply. For the first order, it's 151 out of 1,118. 151 divided by 1,118. That's the probability the first order is from restaurant D. For the second order, there's only 150 orders left out of 1,117 from restaurant D. So I'm going to multiply that by 150 divided by 1,117. And then for the third order, we've already removed 2 orders from restaurant D, so that leaves 149 left, times 149 divided by, now there's 1,116 orders left altogether, 1,116. When I multiply those 3 numbers together, I get a probability of about 0.0024, rounded to 4 decimal places. So if I go back to the question, 0.0024. Enter. Fantastic. Okay, next question. Okay, now this one, we're going to apply something called the 5% rule. And to be honest, I don't know why they don't apply the 5% rule in the previous example. I should write Triola a question about that. But in this one, we're going to apply the 5% rule. So this one says, I'm going to write these numbers down, 360 failures. There's 360 firmware failures out of 8251. 360 out of 8251. So if they randomly select 3, what's the probability the batch is accepted if all 3 of them are okay? Okay, so the probability 3 good is equal to the probability of 1 good. They're going to say raised to the 3rd power. And what the 5% rule is that we're going to sample this without replacement. Well, let me do a little bit of math first, and then we'll get to what I want to get to about the replacement and the 5% rule. So 360 out of 8251 are bad. So to figure out how many good ones, let me clear all this junk out. So it was 8251 minus 360 are the good ones. So that's 7891 are good ones. So 7891 out of 8251 are the good ones. So in theory, if we do this sampling without replacement, on the first one, the probability of a good one is 7891 out of 8251, and then the next one would be 7890 out of 8250, and the next one would be 7889 out of 8249, but they don't do it that way. They appeal to something called the 5% rule. Since we're taking a sample of 3 out of a population of 8251, they say that let's just use the 5% rule, which means we'll just take the probability of one good one and multiply it by itself 3 times. That would be the same thing as sampling with the replacement. Again, in this example, they use that 5% rule. With the previous example with the restaurants, they didn't. I'm going to have to ask Triola why it's different. Anyway, so to get the answer for this one, what I'm going to do is take the number of good ones, 7891, divide it by the total number, which is 8251. And that is going to give me the probability of one good one. And then for 3 good ones, I'm going to raise that to the third power, raising it to the third power, and I end up with 0.8747. Let's see if they like that number. 0.8747. Oh, they want 3 places. Let me go back and look at that. 3 places, 0.875 to 3 places. Okay, so 0.875, 0.875, and that's about an 87% chance. So I would say it's not certain that the batch will be accepted, but it's likely that the batch will be accepted. Let's hope for the best here. Fantastic. Okay.